covering sections 3, 4, and chapter 3. Remember on last week and yesterday we covered solving one-step equations using addition and subtraction. Today we're going to be covering one-step equations using multiplication or division. Each of you should have a map as well as your algebraic tiles. And we're going to do some whole group work in understanding how to do division and solve equations using those algebraic tiles. And from the algebraic tiles, which are your manipulatives, we're going to move on to your doing it on paper, okay? Yes. So we'll begin with our first activity. Give me 1 moment. I'll scroll it up so we can start. And the question for today is going to be, how can you use multiplication or division to solve equations? So this is what I want to share with you first. When you're given equations, say we're given an equation that says 5x, we'll do 2x. 2x equals 6. Now you all remember that our algebraic tiles that represent variables are the long tiles. Hold those up for me. Hold at least one up. It's going to be red on one side, yellow on the other, but they're the long tiles. So we have them here, right? Yes. And then on the other side of the equation, I'll say -6. We'll have 6 negative tiles. Now, whenever aligning your variables, the number of variables you have with the number of constants you have, we're going to put -3 by each one. Split them up equally. We'll use an example of 2 friends wanting to eat 6 cookies. And they're going to divide those 6 cookies evenly. So it would be 3 negative numbers, right? Yes. So we have 2x, which are your 2 algebraic tiles that represent your variables. And then we have 6 cookies that would be aligned with those. Got it? And I'll put the equal sign right here. Now, what is the goal when we are solving an equation? Because this is considered an equation. And why is it considered an equation? Can someone raise their hand and tell me? Can someone raise their hand and tell me why this is considered an equation and not an expression? Yes, sir. We have the equal sign. That determines if it's an equation or an expression. So now what I'm going to do, I have 2x equals a -6. What's the goal when we have a variable in an equation? Can someone raise their hand and tell me? Jalen. I can't hear you.
Trying to get it by itself.
We're trying to get the variable by itself, or we'll use the word to isolate, which means to get something by itself. We're trying to isolate the variable. So we're going to isolate the variable 2x. Can you tell me what form this 2x is in? What operation is present in this equation where 2x is? Can anyone raise their hand and share it with me? Yes, ma'am. It's multiplication. Now, whenever we're going to isolate a variable based upon the form that it's in, we're going to do what? It's called the opposite in order to cancel it on one side of the equation to get something to the other side. So what are we trying to get to the other side of this equation in this problem? 2x equals -6.
So you take 2. Wait, you put 2 in.
What are we trying to move to the other side of the equation? I can't hear you. Yes, ma'am. No, x is going to be isolated. So what are we trying to move to the other side of the equation? Yes, Kevin?
2.
The number 2. That's what we're going to be moving over here. Now, one of the rules of working an equation or a one-step equation is whatever you do on one side of the equation, you must do on the other side. So when we prepare to move this 2x equals a -6, when I'm prepared to move this 2, since it's in multiplication form, how do I create the inverse or the opposite operation of multiplication?
Divide.
You raise your hand and I'll acknowledge you. Yes, sir.
Divide.
By dividing. What am I dividing again?
2x by -6.
I'm dividing what?
2 by
The 2. So I'm gonna divide 2 on both sides, correct?
Yes.
And then 2 into a -6 gives us what?
-3.
Okay, now I'm gonna show you this effect with the algebraic tiles. I have 2x equals a -6. And because I have 2 friends, each of them have 3 cookies apiece, right? So when I'm ready to move this 2 over, I still need to leave at least what? 1 variable on this side of the equation. And then I'll cancel out the other, okay? So I'm gonna cancel this out. What would that equation look like now? What would that look like?
1x.
So we'll say this is x, it'll be x what?
1x equals -3.
-3, is that not what we have here?
Yes.
You see how I did that? We're gonna look at our first example in our book. Well, it's here on the screen, but you have the algebraic tiles on your desk. What I need you to do for me quickly is set this equation up. 3x, so what does 3x represent?
3 variables.
3 variables, so in one box, on the right side, the left side of your equation, you're gonna put 3 variable tiles. Is this a positive or a -3?
Positive.
So I need to see 3 yellow tiles on the left-hand side of your equation. 3 yellow tiles, good job. And then on the other side of the equal sign, you'll have -12. Now, these small tiles represent what? Integers or numbers, right? So this side is what? The yellow side is what?
Positive.
And the red side?
Negative.
So if I have a -12 here, how many of those tiles do I need in what color? In the other box.
Red. Positive 12 tabs. No, I mean, negative red 12.
So I should have 12 red tabs. So now I'm going to teach you something today that's going to help you going forward. You have 3 yellow tiles, and I'm going to use this desk up here in the front. I want a tile at the bottom of the box, 1 in the middle, and 1 at the top. So put a tile at the bottom, the middle, and at the top. Across from each of those tiles, since you have 12 red small squares, I need you to divide them up evenly. So you have 3 friends that are going to share 12 cookies. So I need you to divide them up evenly along the lines of those variables. So you have 3 variables, and across from each variable, I need how many red tiles?
3.
How many red tiles?
4.
4. 3 times 4 is 12. So if I have 1 at the bottom, 1 in the middle, 1 at the top, I'm going to need 4 red ones here, 4 red ones here across from that one, and then 4 red ones there. So I should see excellent, superb, great job, great job. Let me see if they're doing them in the back. Roosevelt, the equation says 3x equals -12. So the other box on the other side of the equation is where those other tiles would go. Good job, excellent job, Natalia. Great job, Brianna. Good job. Let's see what you have, Jaden. You're Jaden, right? So you have 3 variable tiles, right? And across from each of those tiles, put 1 at the top, 1 in the middle, the variable tiles, and then 1 at the bottom. So look at the person next to you and see how theirs is set up. They set yours up exactly the same way. Okay, now that we've done that, now we're going to solve this equation. 3x equals -12, right? Am I right?
Yes.
So what form or what operation are we looking at right here? Raise your hand if you want me to identify it with you. Yes, Walter.
Multiplication.
Right. So with multiplication, if I'm going to move this, what am I moving? Am I moving the 3x?
The 3.
Just the 3 alone, correct. So we're isolating a variable or leaving the variable over there by itself, right? Am I correct?
Yes.
And we're going to do what?
Divide 3.
We're going to divide 3. And why are we dividing 3 on both sides?
It's the Opposite.
It is the inverse or the opposite of the operation that's currently in place. So we're gonna divide 3 on both sides. So with me dividing 3, I'm gonna cancel this one. And how many times does 3 go into negative 12?
Negative 4.
Oh,
Negative 4. So x is going to equal a negative 4. Now, remember, you should have only one variable at this time if you're creating this answer. So how would you create that answer if you had 3x equals negative 12? So if you cancel out the 2 variable tiles, what else do you have to cancel out to match it?
The 2 rows of
The 2 rows of your integer tiles. Brianna, you have a question?
I got answers.
I'm gonna take a quick peek. So you didn't have to put any positive tiles there because you're not doing addition and subtraction. You're creating equal pairs, okay? Good job, excellent, excellent. Let's see what we have. Good job, excellent. Good job, people. If you have to, just kind of glance over and see what your partner next to you is doing, it's okay. Because sometimes watching someone else will help you. All right, everyone has done that. Let's move up. Are there any questions so far?
No.
So now we're going to try an equation 2k, and I need you to set this equation up. 2k equals negative 8. 2k. So what does 2k represent?
2 variables. 2,000.
2000.
I need a hand raise. What does 2k represent in this equation? 2k equals
Oh,
negative
2K
eight.
is it's two K's.
Two variables.
I just
So it's a variable with a value of 2. So whatever it is, you're going to have 2 of them. And then it says equals a negative 8. So you got 2 friends who is going to share 8 cups of coffee. Yes. Good job. Excellent. I'm looking to see if you've set the equation up correctly. Good job. Superb. I'm still waiting on you to set up your equation. That's in the chat. Good job. Excellent. I see in the back. Still waiting for a couple of people. Good job. No. So the long tiles are your variable. If you have 2k, how many long tiles do you need in the first box, Kevin? So get rid of the small integer tiles out of there. Now separate them. One moment. Separate them. Now, if you have 8 that you're splitting between the two, it's going to be 4 with the first variable and 4 with the second variable. Excellent job. Now we're going to solve this. We're going to solve this 2k equals negative 8. I'm isolating what? Raise your hand and tell me. Yes, sir. I'm isolating the variable. What am I doing with the 2? Yes.
You're putting it to the adding it to that side.
I'm adding it.
Yeah.
Hold on.
You're putting it to the other side so you can divide.
So I'm going to divide. And why am I dividing 2 on both sides?
Because it's the opposite.
Raise your hand. Yes, sir.
Because it's the opposite of multiplication.
It's the opposite or inverse of the multiplication of 2 times k. And so I'm going to cancel. 2 goes into negative 8 how many times?
4. Negative 4.
Negative 4. So k is going to equal a negative 4.
I got that.
I need to see if that's what you've done. When you cancel out one of the variables, when you cancel the variable, you also cancel the integers with it.
Just wanted to make sure I heard this correctly.
Good job. Excellent. Superb. Good job. Good job. I'm still waiting on you to cancel. You're going to have 1 variable tile left. You know you always have to leave a variable. And with that variable tile, you have 4. Kevin, waiting on you to cancel them out.
Okay, I just wanted to make sure because I thought you said. Okay, my apologies.
Got it.
All right.
I'm still waiting on you to get rid of some of those tiles. You don't have a variable to match, there should be no tiles. Excellent, excellent. Good job, everyone. Let's try D. No, before we go to D, we'll do negative 15 plus 3t, and I'll put it on the board so you can see it. Negative 15, so now it's changed, because before you had 2k, your variable equals some number. Now you have the number first, which will equal
3T.
So set that up.